our Department of Chemistry. On the previous sections, we have already discussed about this what is the polymer, introductions to polymers, and what is the degree of polymerization, and what is the thermoplastic and thermostatic polymers can be differ from each of this, and the preparation of the polymers is based on this polyethylene, PVC, Teflon, nylon, bakelite, and today this topic is going on from this polylactic acid, that is PLA, that is the lactic acid which is fermented from the sugarcane, maize, corn, starch. This is a major sources how the lactic acid can be converted. So it is a biodegradable and bio-based polymers which can be degradable from this when compared to this other polymers, and it has a more thermoplastic material which is based on this polymer, and it has a renewable sources of the maize, corn, starch and the sugar cane which is extracted the pulp from the extracted this plastic material for using this bioplastic polymer as a polylactic acid, and the two methods which are used in this polylactic acid is considered as a lactic acid of CH3, CHOH, COOH. The formula for this lactic acid, and it is classified into two types. One is a direct condensation polymerization and another one is a ring opening polycondensation, which is formed by this format. That is a direct condensation of polylactic acid, which is used for the formation of the monomer from lactic acid as a source of bioformed plasters, and the ring opening polycondensation, which is formed by this structure of the acids, which is formed by the OH and COOH group to form this polylactic acid. So next, the preparation of polylactic acid, how the lactic acid can be converted into this polylactic acid. That is, the polylactic acid is, the formula of lactic acid is CH bond CH3 OH C double bond O and OH. Lactic acid under the polymerization reaction with the 200 degrees Celsius, it forms as a C double bond O CH CH3 and bond O. How this water molecules will remove from this OH group, the NH2 groups, that is OH, and from this we get one OH will remove, which is removed by minus NH2 group to form this C double bond O and CH3 bond O. With this formation of this double bond, which is converted into a single bond, the repeating units of polymerization, and the properties from using this polylactic acid is considered by the, it has a, and compared to this other polymers, the polylactic acid has a more lactic and shiny resistant properties. It has a more transparent and shiny towards this, and it has a stable at a low temperature process, which is considered by the polymers, and it has a modest and water permeable properties, which is based on this polymers of lactic acid and the preparation of lactic acid, and it has a high grease and oil resistant towards this lactic acid because of the fermented from the starch of this corn and the sugarcane juices, and it has a petroleum-based polymerization reaction which is used in this applications of polymers, and it has a good mechanical, thermal and elasticity properties because of this fermented plants, and it has extracted from this polymers which is used in this 3D printing materials, and it has packing materials which is used in the food and garment textile industries. Based on this varieties and the compositions have mechanical strength and elastic properties, it has a more resistant towards when compared to the other polymers, which is more flexibility and rigidity. And the last is which is has a more, which is used in this medical applications like devices and instrumentation to sterilize the hospital equipments, which is used for the therapies and the homeopathic clinics, and also it is used in the mainly for the textile industries to dyeing the fibers and the cloth materials, which is used from the fermented of polylactic acids, and the disposable materials, which is also used for disposing all solid and waste materials which is used for this, and it has a more excellent properties when compared to this, and the limitations which are used as the polylactic acid is only the limitation is it is fermented from this sugarcane and the other properties. It is the main process for the disinfectant properties, and it is a non-biodegradable to form this structure to polymers. So this is the preparation properties and uses and the polymer structures. Thank you.